A short introduction to the TACC module system. The module system is how TACC organizes its software. When you log in, you can do module list, and that tells you which modules are currently loaded. Now, some of these names mean nothing to you, but look at number 1, Intel 24. That means that version 24 of the Intel compiler is loaded. What does that buy you? Well, for instance, it tells you that the C compiler at the moment is ICX. The C++ compiler is ICPX, and the Fortran compiler is IFX. Um, Now, if you don't want to use the Intel compiler, but the GNU compiler, you would do module load GCC. And you see that it says it replaces Intel with GCC. That is because the two compilers are not compatible with each other. And so if you look, you can have only one loaded. Now, if you do echo TACC CC, you'll see that the C compiler is GCC. So this means that you can write scripts that do taccc minus compile my program.c, my program, or whatever, right? So you now have a compile line that is independent of what compiler you're using. So if you change your mind about the compiler, you don't have to change your script. Okay, let's go back to module load Intel. So at the moment, Intel 24 is loaded, but I can do module avail Intel, and that tells me that Intel 23 and Intel 25 are also available. So if I need some new features or Intel 25 I know has fixed a bug, then I could do module load Intel 25. Okay. Um, and if I decide I always want to use this, I can now actually do module save, and that saves my default collection with Intel 25 rather than the default Intel 24. Okay, let's let's load some software. Let's say I'm compiling something that uses the HDF5 library. So I do module load HDF5. And what does that give me? Well, it now defines TACC HDF5 dir as the location of the HDF5 library. Inc is the location of the include files, and lib is the location of the library files. So now I can write taccc minus compile my program.c with include path of TACC HDF5 inc. Okay, so I don't have to know where my HDF5 library is. It gets found as long as I've loaded the HDF5 module. Oh. All right, so I have HDF5 loaded, and now part of the fun of the module system is that if I now do module load, say GCC, and I want to use 15 explicitly, then it says it reloads HDF5, and now if I do TACC HDF5 dir, it's found HDF5 somewhere in the GCC 15 compiler. Okay, so no matter what compiler I've loaded, thanks to the module system, I always have an HDF5 that is compatible with that compiler. Okay. Of course, there is module unload. If you want to know precisely what the module system does, module show HDF5. You don't always need that, but oh, you can do module help HDF5, by the way. That tells you, oh, and there is an HDF5 bin tag, HDF5 bin. And so that's the location of all the binary files, executables that come with HDF5. Now, in the module show, you see that there is something with package config path, which means that I can do package config compile flags HDF5, and it gives me the flags that are necessary for compiling with HDF5. So now I can do TACC, CC, my program.c, and I use package config C flags HDF5. And I can also do package config libs, etc. Okay, so again, completely independent of the compiler, my flags are always correct. And you see that there is a line with the CMake prefix path, which means that HDF5 will also be found from CMake configurations. So as an example, uh, so in your CMake configuration, you can now do find package HDF5, and as long as the module is loaded, HDF5 gets properly found by CMake. Okay, now let's say that I do a number of projects with HDF5, and so I sometimes want to make it easy to have this set up. Let's see, what do we have? All right, GCC 15 and HDF5. So I can do module save. Let's call this GCC HDF. Okay, so now the current selection of modules is saved. If I do module reset, I get the standard configuration with Intel 24, but I can now do module restore, what did I call it, GCC HDF. And now module list. I have my collection of JSON. Okay, so I can make module collections based on what project I'm working with. Okay, that's it.